In this video, we're covering section 4.2, isosceles in equilateral triangles. We're going to apply theorems about isosceles in equilateral triangles to solve problems. So, isosceles triangle, a triangle that has two congruent sides. So that is an isosceles triangle. I like to use the inclusive definition, which means that as long as it has two congruent sides, we have an isosceles triangle. So this is an isosceles triangle, and it's a special type of triangle that is a equilateral triangle because all three are the same. So theorem 4-1, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay? So here are the two sides of our triangle. If these two sides are congruent, then these base angles are congruent. That's what we'll call those are the base angles. And the converse, so that was the initial, now we're doing the converse. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if the two sides are congruent, then the base angles are congruent. If the base angles are congruent, then the two sides are congruent. Those are both true statements. So what we are allowed to do now is to find missing values in these types of triangles. Okay, so I have 108 degrees, and then the two base angles of an isosceles triangle. So we note that the two sides are congruent, so we have an isosceles triangle. That means that x and y have to be congruent as well. So I'm going to call y equal to x. So 2x plus 108 has to add up to 180 degrees because the three angles in the triangle add up to 180 degrees. So we're going to subtract 108. So that gives me 72. So x equals 36. So this angle is 36 degrees, and this angle is 36 degrees. Now in this one I didn't mark it, but let's find x and y here. Well, y is 63 degrees because it's an isosceles triangle and the base angles are congruent. So 63 times 2, or we can go 63 plus x equals 180. Well, that together is 126. So I'm going to subtract 126 from both sides. So x equals 54. So now we know this angle is 54 degrees. What are the lengths of all three sides of the triangle? Okay, now we have an isosceles triangle here. We know those base angles are the same. So that means two of these sides have to be the same. And it's the angles, or the sides across from the angles. So this side and this side. So now that we know that those two sides are congruent, I'm going to write an equation. X plus 12 equals 8x plus 3. That means 9 equals 7x, so x equals 9/7. Now I can plug that in, and this would give me 12 plus 9/7, so I'm just going to call that 13 2/7. This is 8 times 9/7 plus 3, so 72/7 plus 3 is 13 2/7. It's the exact same. And then we have 6 times 9/7 minus 12. So this number doesn't work very well because I think we end up with a negative side length. But that's the idea on how you can solve this type of triangle. All right, theorem 4-2. If a line or segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. So what that means, if we have an isosceles triangle and a line segment bisects the vertex angle, so we have our base angles down here, and that's called our vertex angle. Then our conclusion is that this is also a perpendicular bisector. Okay, so our conclusion is in purple. Means if we have an isosceles triangle and a lines and angle bisector, it will also cut the opposite side in half and be perpendicular to it. An equilateral triangle. An equilateral triangle is equiangular. That means equal angles. And an equiangular triangle is equilateral. So, if all three sides are congruent, then all three angles are congruent. If all three angles are congruent, then all three sides are congruent. And that finishes our video for section 4-2. Thank you for watching.